Hello there, and welcome to the Sleepy Space Channel. Tonight, we'll be drifting gently outward, past the last familiar edge of our own neighborhood, to ask a soft and very old question: what hides beyond the boundaries of our solar system? We will begin far from home, beside the small, worn spacecraft that left long ago and are still quietly traveling. From there, we will cross to the nearby stars and pause beside a dying giant and visit the lonely worlds that drift with no sun at all. We will rise above our own galaxy and meet the still dark centers of things and travel, at last, all the way to the edge of everything that can be seen. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too. One sleepy soul at a time. But for now, there is nothing you need to do but settle in. Let your shoulders soften. Let your breathing slow. Allow your eyes to grow heavy. Let the day fade away. Let's begin. Part 1. The spacecraft already leaving. We do not begin this journey at home. We begin already far from it, out in the quiet dark where the planets are only memory, and the sun is one bright star among the many. There is no countdown here, no rising flame, no moment of leaving. We simply find ourselves out in the long night, drifting, and we are not alone. Nearby, moving the same direction we are moving, there is a small machine. It is older than most of the people who might be listening tonight. It is worn, and it is silent, and it is still going. It left a long while ago, and it has never once looked back. This is where the journey starts, because this is where the journey already is. The question we are following tonight is a soft and very old one. What hides beyond the boundaries of our solar system? What is out there, past the last familiar edge of the neighborhood we know? And the gentlest way to answer that question is not to read about it, but to travel it, slowly, the way you might walk a long shoreline at dusk. So, we will travel. We will drift outward, room by widening room, and we will let the dark show us what it holds. The restlessness that brought us here is older than any spacecraft. For as long as there have been people who looked toward the far edges of things and wondered. The same quiet pull that once carried travelers across oceans and over mountains and into deserts eventually turned upward toward the sky, and then further still, outward, into the space between the worlds. The machines drifting near us now are the physical shape of that wandering. They are small, and they are simple, and by the measure of any imagined future they are almost crude. But they are real. They are out here, and they are still moving. There is something steadying in that thought. Whatever else is uncertain about the universe, this much is plainly true. We have already begun to leave. 5 of them, in all, are on their way out forever. 5 spacecraft, built by human hands, are following paths that will never curve back. These are not orbits. An orbit returns. These are escape trajectories, one-way roads, and the 5 travelers on them will leave the solar system and simply keep going into the wider galaxy beyond. Each of them was built to study the outer planets, and each of them, having finished that work long ago, did the only thing left to do. It kept traveling. None of them was designed to be a messenger to the stars. They became that only by carrying on, the way a footpath becomes a road simply by being walked far enough. The first 2 were a pair, launched within a year of one another, in the early 1970s. The first of that pair was the very first machine ever to cross the wide belt of asteroids and reach the giant planet Jupiter. That crossing itself was an act of quiet faith. No one knew, before it tried, whether a spacecraft could pass safely through the belt at all, or whether the drifting rubble there would simply end the journey. It passed through untouched. And then it sent home the earliest close pictures of that enormous striped world and of its largest moons, and it measured the planet's thick atmosphere and its powerful magnetic field. It learned something quietly strange, too. It found that Jupiter gives off more heat than it receives from the Sun, that the giant planet has a slow inner warmth of its own, a leftover heat from its long-ago making. That first probe the silent many years ago. Its faint voice grew too thin to hear, the way a sound fades, not suddenly, but by gentle degrees. But it is still out there, drifting outward at around 12 kilometers every second, already more than 100 times farther from the Sun than the Earth is. Its twin took a different road. It used the gravity of Jupiter to swing onward, the way you might use a river current to carry a boat without ever lifting an oar, and it went on to the ringed planet Saturn. It gave us our first close look at those famous rings, and at 2 of Saturn's moons, before it too grew quiet and could no longer be heard. It moves outward now, in its own direction, on its own long and patient path, alone. The 2 twins, launched so close together, are now traveling away from one another as much as away from home, each following the gentle logic of its own trajectory, and the distance between the 2 of them grows wider every year. Then came the next pair, and these are the ones that traveled farthest. They were launched in the late 1970s, and they were built to take advantage of a rare arrangement of the outer planets, a quiet alignment that comes only once in many human lifetimes, when the giant worlds are spaced so that a single craft can pass from one to the next, each planet's gravity flinging it gently onward. The first of them is, today, the most distant object that human hands have ever made. It is the fastest of all the outbound travelers, moving at around 17 kilometers each second, which is about 3.5 times the Earth's distance from the Sun in a single year. Along its way, it discovered new moons of Jupiter, and it confirmed that the planet's great red spot is an enormous, long-lived storm, a storm wider than the whole Earth, a storm that has been turning for longer than anyone has been watching it. It watched volcanoes erupting on one of Jupiter's moons, the first eruptions ever seen on any world but our own. And then it traveled on, past everything, until it crossed a boundary we will come to in a moment, and entered the true space between the stars. Its twin is the only machine ever to visit all 4 of the giant planets. It went to Jupiter and to Saturn, and then onward to the 2 far blue worlds, the ones almost no spacecraft has ever seen up close, and almost certainly none will see again for a very long time. Its pictures hinted at hidden oceans beneath the icy surfaces of distant moons, oceans sealed under crusts of ice, dark and quiet, and possibly liquid. It revealed faint rings and many small moons around worlds that had seemed plain and featureless before. The gravity of the last giant planet bent its path gently downward, below the flat plane where the planets travel, and it carried on from there, outbound, into the dark, on a road tilted away from everything else. The 5th and last of them is the youngest. It left long after the others, in the middle of the 2000s, and even though it is quick, it can never catch them, because they had such a long head start, and a head start in space, once given, can never be taken back. This one used Jupiter for a push, and caught the first ever video of a volcano erupting on one of Jupiter's moons as it passed, a slow plume rising silently above an alien horizon. Then it traveled on, for years and years, to give us our first close look at distant Pluto and its large moon. For most of human history, Pluto had been only a faint and nameless point of light, too far to be anything more. This probe made it a place with mountains and plains and a thin and delicate air. It mapped their faces and studied that thin atmosphere, and afterward it flew on still further to brush past a small icy body even deeper out, far beyond Pluto, in the cold scattered fields at the edge of the Sun's family. Its power source is slowly fading now. One by one, in the years ahead, its instruments will go quiet, and then it will travel on in silence, like the others, never to return. Before any of these 5 could reach the true space between the stars, they had to cross an edge. It is an edge most people never think about, and yet it is the real boundary of the Sun's own territory. The Sun does not simply stop at its glowing surface. It breathes outward. It blows a steady wind of tiny charged particles in every direction, all the time, and that wind pushes against the thin gas of the galaxy and carves out an enormous bubble. We live far inside that bubble. Every planet orbits within it. Every comet, every asteroid, every drifting grain of the solar system sits inside the Sun's slow exhale. It has a name. It is called the heliosphere, and it is the Sun's own quiet country. The heliosphere is shaped a little like a soft teardrop. It is blunt and rounded on the side that faces the direction the Sun is traveling, because the Sun is not still either, but moving steadily through the galaxy, and the bubble presses gently against the gas ahead of it. And it is drawn out into a long, gentle tail behind, the way smoke trails behind a moving lamp. Its outer wall lies far past the orbit of the most distant planet, somewhere beyond 100 times the Earth's distance from the Sunday. At that wall, which is called the heliopause, the pressure of the Sun's wind finally comes into balance with the pressure of the thin gas drifting between the stars. The two meet there and mingle in a shifting, complicated frontier of particles and magnetic fields. It is not a wall you could touch. It is not a wall you could see. But it is real, and the farthest of our spacecraft crossed it and felt the change in the particles streaming past, and quietly told us it was there. That message, when it arrived, was a small one, but it meant that, for the first time, something we had made was no longer inside the Sun's bubble at all. It was out, in the gas between the stars, truly away. What lies ahead of these 5 small machines is almost beyond holding in the mind. The farthest of them, moving steadily, will need tens of thousands of years simply to pass through the inner edge of the enormous cloud of comets that surrounds the solar system at its outermost reach, a faint, spherical shell of icy bodies, so distant and so dim that we have never directly seen it, and only know it by the comets that fall inward from it. Tens of thousands of years more to leave that cloud fully behind. And after that, the long drift between the stars, measured not in years but in ages. In tens of thousands of years one of them will pass, at a distance, by a faint star, the gentlest sort of encounter, a quiet nod across light years of dark. Their power will fail long before any of that. Their voices have already faded, or soon will. And after that, they will simply drift. It is worth letting yourself rest for a moment on what becomes of them. Their fate is uncertain, and it is oddly peaceful. It is possible that, far in the future, they will be found again, gathered up gently by descendants who have learned to travel between the stars, and set in some quiet museum as the first small steps of a young species, treasured the way we treasure the first frail tools of those who came before us. It is possible one of them will strike a stray body somewhere in the dark and end. But far more likely, they will simply drift on, for millions upon millions of years, slowly worn smooth by starlight and by the rare drifting grain of cosmic dust, each tiny impact removing the faintest trace of material, until at last, across spans of time too long to feel, they become scattered debris among the stars. And even then, they will be a debris that once carried maps and music and the name of a small blue world. The thought is not a sad one when you hold it gently. It is simply the long, slow shape of having gone somewhere. So this is where we begin. Not lost and not lonely. Simply outbound, in good company, drifting the same gentle direction as 5 patient machines into the dark, in no hurry at all. They are humanity's first timid footsteps past the doorstep of home. And there is something deeply restful in the thought that they will go on taking those footsteps, quietly, long after everyone who built them has gone to sleep for good. We will leave them now and travel faster than they ever could. But they will keep going. They always will. And somewhere far ahead of us, on a road we are only beginning to imagine, they are already on their way. Part 2. Crossing to the nearby stars. Now, we let the journey loosen its grip on real speed. The 5 probes drift behind us, doing in centuries what we are about to do in the space of a breath. This is an imagined voyage, and an imagined voyage may travel as fast as wonder allows. So we will cross light years, the way you might cross a quiet room. The stars that were points of light are about to become places with surfaces and weather and families of worlds and stories of their own. Within about 50 light years of the Sun, there are well over 1,000 systems of stars. And because so many of those systems hold not one star but 2 or more, bound together in slow mutual orbits, the true count of our near-stellar neighbors climbs past 2,000. They are not all alike. Some are dim and cool, small red embers that give off only a faint glow, the most patient and the most common stars there are. Others are brilliant and white, far brighter than the sun, blazing in the dark, the kind that make the familiar shapes in the night sky. Tonight we will not try to visit them all. A life is too short for that, and a sleepy hour shorter still. We will simply choose a handful, the most rewarding ones, and drift gently from one to the next, the way you might wander a quiet street and pause at the houses with the most interesting lamps. It helps, first, to understand the shape of the neighborhood. The stars nearest to us are mostly small and faint. The little red dwarfs greatly outnumber the bright stars, even though it is the bright ones that catch the eye when you look up at night. This is one of the gentle truths about our galaxy. The dazzling stars are the rare ones, and the quiet ones are the rule. Many of these nearby stars carry their own planets, quietly, so that the night sky overhead is fuller of other worlds than it looks, full of places no eye will ever see directly. And the neighborhood is not still. The whole gathering of stars drifts, slowly, each on its own path, each carried along the great turning of the galaxy at its own pace, so that over very long stretches of time, the title of nearest star passes gently from one neighbor to another, the way a quiet word might pass around a room. The sky, we know, is only the sky of this age. Given enough time, every constellation softly rearranges itself. It is worth holding, too, just how far apart these neighbors really are, because the word neighborhood can make the stars sound close, and they are not close in any ordinary sense. The nearest star to the Sun is a little over 4 light years away, if Bagot, and a light year is a distance almost too large to feel. The fastest of our outbound probes, the one that has traveled farthest of anything we have ever made, would need tens of thousands of years simply to cross that single gap to the nearest star. The space between the stars is mostly, gently, empty. And yet that emptiness is not a sad thing. It is the quiet that lets each star be its own place, undisturbed with its own worlds and its own slow life, never crowding its neighbors, never colliding with them. The wide dark between the stars is what keeps the neighborhood peaceful. We are only able to drift from one to the next so quickly tonight because this is an imagined journey, free to move at the speed of wondering, and wondering, unlike any ship, has never had to mind the distance. Our first soft landing is at a star called Ross 128. You cannot see it from Earth with your eyes alone. It is a dim red dwarf, small and cool, and it asks for a telescope. But it is a calm star, and that calmness matters. Its light is steady and regular. It rarely flares, rarely throws out the bursts of harsh energy that some small stars do, the sudden tempers that can scour the worlds around them. It is, in that sense, a gentle host, a quiet hearth. And around it there moves one of the closest temperate worlds we know of, a planet a little more massive than the Earth, perhaps a third heavier, and, if its makeup is anything like our own, somewhat larger across, with a surface gravity only slightly stronger than the gravity you rest in now. That planet orbits very close to its small, cool star, far closer than the Earth orbits the Sun, only about a 20th of that distance. It swings around its star in just under 10 of our days, so that a whole year there is shorter than a week and a half here, a year that turns over again and again, while a single month passes at home. Sitting so near, it has very likely become what is called tidally locked, turning one face always toward its star and holding the other always toward the dark. On such a world, there would be no sunrise and no sunset, only an unmoving star fixed forever in one part of the sky, and on the far side, a night that never ends, and somewhere between them, a soft ring of perpetual gentle dusk. And yet, because the star is so faint, the world is not scorched. Its estimated temperature is mild, close to the Earth's, perhaps a touch cooler. It is one of the more promising of the gentle nearby worlds, and the whole system is drifting our way. In tens of thousands of years, it will be a closer neighbor to us than the nearest star is today, quietly trading places in the slow dance of the neighborhood. We drift onward, 12 light-years further, and we come to a star, sometimes called Luyten's star. It is an orange-tinged red dwarf, small, only about a quarter of the Sun's mass, far too faint to find without a telescope. But it is a quietly remarkable little star, because it holds one of the richest families of worlds among all our near neighbors. 4 objects have been found around it. 2 of them are confirmed planets, and 2 more are candidates, still waiting patiently for confirmation, the way much of the sky is always waiting. The first confirmed planet there is a super-Earth, a world several times the mass of our own, and it orbits within the gentle band astronomers call the habitable zone. That phrase sounds technical, but the idea behind it is soft and simple. It is just the ring of distances around a star where a world receives roughly as much light as the Earth receives from the Sunday. Not too much warmth, not too little. A place where, if other things aligned, water could rest on a surface as a liquid rather than a frost or a steam. The planet's estimated temperature is mild, which makes it one of the more interesting worlds in our whole stellar neighborhood, and its surface gravity, were you somehow to stand on it, might not feel so very far from home. The second confirmed planet is closer to the Earth in mass, but it orbits much nearer its star, hurrying around in only a few days. It is very likely a hot and harsh place, probably tidally locked, probably stripped long ago of any air it might once have held. And further out, in the cold, 2 more worlds wait, still unconfirmed, thought to be ice giants, drifting in the long chill beyond the star's gentle zone, slow and frozen and dim. Onward again, and now the journey reaches something brighter. Almost 17 light-years from the Sun, we come to Altair, a brilliant blue-white star, nearly twice the Sun's mass, and one of the most brilliant points of light in the whole of Earth's night sky. If you have ever looked up on a clear summer evening and found a particularly bright star, there is a fair chance you have seen this one. Altair has a secret, and the secret is its spin. This star turns astonishingly fast. Where our own Sun takes the better part of a month to complete a single slow rotation, Altair completes a full turn in well under a single day, with the material at its equator racing around at hundreds of kilometers every second. That tremendous spin does something visible, something you could see if you could draw close enough. It flings the star's equator outward, the way a spun thing always bulges at its middle, so that Altair is not a neat sphere at all. It is wider across its middle than it is from pole to pole, swollen into a soft, flattened, lens-like shape. And that shape changes the star itself. The bulging equator, pushed outward and away from the star's hot core, is cooler and a little dimmer. The poles, drawn closer in, are hotter and brighter. A single star, glowing unevenly, brighter at its top and bottom than around its waist. Altair holds the quiet distinction of being the first star beyond the Sun whose surface features were directly seen, the first time another star became, to our instruments, not just a point of light, but a place with a face, a thing with a shape. No planet has been confirmed around it, but it appears to be wrapped in faint rings or a soft haze of gas, which scatters its light into a gentle halo. Beautiful to imagine, that soft, glowing ring around the swift star. A little frustrating too for those who study it, because the haze veils the very star it surrounds. 25 light-years out, we slow again, beside a system that long fooled us. It is called Fomalhaut, and for a great while it was thought to be a single bright star, one clear point of light. Only later did we understand that it is 3 stars, bound together by gravity, but spread across an enormous distance, so far apart that it is one of the widest known multiple star systems anywhere near the Sunday. The 3 of them are a family, but a family living in rooms so far apart that a message between them, traveling at the speed of light, would take years to cross. The bright main star of the 3 is young and hot, larger and more luminous than the Sun, and it is the one that people have watched and named since ancient times, never knowing, through all those centuries, that it had quiet siblings at all. Around it lies something lovely. A wide ring of gas and dust circles the star, a great soft band of debris, and it is thought to be an active nursery, a place where small new bodies are still slowly gathering and forming, grain drawing to grain, the patient early work of making worlds. It is a favorite thing for astronomers to study, that bright, encircling ring. There was once an object in that ring that looked very much like a giant planet, and for a time it was treated as one, and even given a name. But longer looking changed the picture, as longer looking so often does. It is now thought to have been an expanding cloud of debris, most likely the slow aftermath of a collision between asteroids or comets, a soft, expanding smudge rather than a solid world. Even a confident sighting, it turns out, can soften and change when you watch it patiently enough. The other 2 stars of the system are far quieter. One is a cooler orange dwarf, off at a great distance from the bright main star. The other is a faint red dwarf, so remote that a single orbit around the main star takes it millions of years to complete, one slow circle, while whole species rise and fall on some distant world. Our last gentle stop among the nearby stars is a giant near the end of its life. A little over 37 light-years away, we find Arcturus, the brightest star in the northern sky and one of the brightest in all of Earth's night. Arcturus carries a quiet lesson, and the lesson is about the future of stars like our own Sun, which makes it a fitting place to pause before we move on to a far larger dying star. This star began its life much as the Sun did, only a little heavier. It spent its long, bright middle age the same way our Sun is spending its own now, fusing hydrogen calmly in its core. But it has now used up that core hydrogen, and so it has done what such stars do when their first fuel runs low. It has swollen. It has eased outward into an orange giant, its width now around 25 times the Sun's, its surface cooler than the Sun's, and glowing in a warmer, gentler color, but its total light far greater than before, because it is simply so much larger. Arcturus is the brightest star of an enormous slow river of stars that bears its name, a stream that is the scattered wreckage of a small galaxy, our own Milky Way, absorbed long ago in the far past. The stars of that river still move together, gently, through our galaxy, sharing a common drift, like the lingering current of something that has long since dissolved into a larger sea. And Arcturus shows us, calmly, what awaits our own Sunday. Far in the future, in billions of years, the Sun too will use up the hydrogen in its core. It too will swell, and cool at its surface, and redden, and grow enormous. And then it will shed its outer layers softly into space and settle down to cool, for ages upon ages, as a small, dense ember. There is no alarm in this. It is simply the shape of a star's long life, and Arcturus, glowing quietly in the northern sky, is a gentle preview of it, a distant elder showing the young Sun its own far road. This is what the nearby stars want us to understand before we move on. They are not decoration. They are not a scatter of pretty lights on a dark ceiling. Each one we have drifted past is a place, with a temperature and a spin, and a family of worlds, and a stage of life all its own. One is calm and steady. One holds a rich little family of planets. One spins itself out of round. One is a wide and ancient family of 3. One is an elder, swollen and gold, showing the future. Seen this way, the night sky is less a scattering of sparks and more a quiet neighborhood of houses, each one with a lamp burning softly in its window, each one with someone's idea of home inside it. We are among them now, and the smallness of our own home is nothing to grieve. It is simply one calm house among many, with its own warm light, and we have only stepped out the door to wander. Part 3, Betelgeuse, and the lives of the stars. We come now to a single star, and we let the journey pause here a while, because this star has something to teach us. It is enormous. It is old. And it is dying, slowly, in the last long chapter of its life. Its name is Betelgeuse, and standing near it lets us understand, gently, the whole great story of how stars live and how they end. It is the kind of star that, once explained, quietly changes how the night sky looks to you ever after. Betelgeuse is what astronomers call a red supergiant. It holds roughly 17 times the mass of our Sunday, and its size is almost impossible to truly feel, because nothing in ordinary life prepares the mind for it. By our current rough measurements, its diameter is somewhere between 700 and nearly 900 times the width of the Sunday. Let that settle for a moment. If Betelgeuse were set down where the Sun is, its glowing surface would reach out past the orbit of Mars and swallow much of the asteroid belt. The Earth would not orbit such a star. The Earth would be far inside it. The inner solar system, all of it we know as the warm and rocky region, the whole familiar arrangement of small worlds, would simply be within the body of the star, lost somewhere in its enormous and tenuous outer layers. And yet, despite all that vastness, Betelgeuse has no sharp edge. It does not end cleanly, the way the Earth ends, at its surface, the way you might draw a line and say, here is the world, and here is the sky. Its outer layers are so thin, so rarefied, so gently spread, that the star simply fades outward into a soft nebula of cooled material that surrounds it. That nebula is built from the star's own breath. From matter it has shed, and wind it has blown across long ages, gathering around it like mist around a lamp on a damp evening. Where exactly the star stops and the mist begins is not a question with a clean answer. The density of the star at its blurred edges is barely greater than the density of the nebula beyond. The supergiant just thins and becomes the dark, with no border anywhere that you could point to and name. The light of Betelgeuse is strange and beautiful. Its surface is cool, as stars go, glowing in the soft red part of the spectrum, the color of an ember rather than a flame, the color of something settling rather than something flaring. But because the star is so unimaginably large, it is staggeringly bright. Its glow ranges from tens of thousands of times the sun's output to well over 100,000 times, depending on the moment. And the moment matters here, because Betelgeuse does not hold still. It pulses. It brightens and dims on a slow rhythm of roughly a year, with longer and shorter rhythms folded in beneath, and now and then an unpredictable dimming all its own. Its outer layers are unstable, restless, never quite settled. It is a breathing star, a star that swells and shrinks gently and shifts its light from season to season, never quite the same twice. There is a true and gentle story to tell about that breathing. Not long ago, those who watched the sky saw the light of Betelgeuse drop, and drop sharply, falling to barely a third of its usual brightness over only a few months. It was a noticeable thing, even to people who knew the sky only casually. A familiar star had visibly dimmed. For a while there was open wondering. Some asked aloud whether the great star might be about to end, whether it might be on the very edge of its death, whether the night was about to change. And then, over the months that followed, it simply recovered. Its light climbed back, gently, to where it had always been. The cause, understood later, was not a death at all. The star had breathed out an enormous cloud of gas and dust, a great exhalation of its own material, and that cloud had drifted between Betelgeuse and us, and veiled it, softly, for a season. It was the star exhaling. Not the star dying. Only a great old creature taking a slow breath, and the breath passing across our view and then clearing. There is something reassuring in that small story. What looked, for a moment, like an ending, was only the ordinary breathing of something very large and very alive. To understand how Betelgeuse will end, we step back, all the way back to how a star begins. Every star, without exception, starts as a cold and dark cloud of gas drifting in the space between other stars. There is no fire in it at first. There is only thin, cold gas and dust, and the patient pull of gravity. Gravity is patient, and gravity is steady, and over long ages it draws the densest pockets of such a cloud inward. As they draw together, they compress, and as they compress, they warm. The center of such a gathering grows hotter and denser, and hotter still, the temperature climbing as the material crowds in upon itself, until at last it crosses a threshold. The core becomes hot enough and crushed enough to begin fusing hydrogen into helium. And in that moment, a star switches on. A new light begins, quietly, where before there was only cold, dark gas. That fusing of hydrogen into helium, far down in the core, is the long, calm middle of any star's life. Astronomers call it the main sequence, and more than 9/10 of a star's whole existence is spent there, in that steady, patient burning. The Sun is in that long middle now, and has been for billions of years, and will be for billions more. But stars do not all burn at the same pace. The heavier a star is, the faster it spends itself. This is one of the quiet and slightly surprising truths about stars. The biggest are not the longest lived. They are the briefest. A great massive star like Betelgeuse lives only a few million years, blazing brightly and fiercely and then ending, while a small red dwarf, sipping its fuel with enormous thrift, can burn quietly and gently for many billions of years, far longer than the universe has so far existed. And as the hydrogen fuses, helium gathers in the core, a slow ash building at the center, the leftover of all that burning. What happens when the core hydrogen finally runs low depends almost entirely on one thing. It depends on the mass of the star. Mass is the quiet author of a star's whole fate. It helps to walk this slowly as a soft line of doors, from the gentlest ending to the loudest, because the endings of stars are a spectrum and the loud ones are the rare exception. The lightest stars, the little red dwarfs, fuse their fuel so slowly and so thriftily that they will simply fade over stretches of time far longer than the entire present age of the universe. They will cool, eventually, into dim and quiet remnants, settling without drama into a long, low rest. But none of them, anywhere, has yet had the time to finish. The universe is not old enough. Every red dwarf that has ever lit is still burning, will still be burning long after stars like the Sun are gone. They are the great patient survivors. The middle-sized stars, the ones like our Sun, take a more elaborate road. When their core hydrogen runs low, the core contracts and warms, and the star swells outward into a red giant, just as Arcturus has done, growing enormous and cool and golden. In time, helium begins to fuse into carbon in that contracted core, a second kind of burning, taking up where the first left off. And eventually, such a star sheds its outer layers, gently, releasing them into space as a glowing shell of gas called a planetary nebula, soft and luminous and intricate, one of the loveliest things in the sky. What it leaves behind, at the center of that fading shell, is a white dwarf, a dense and Earth-sized ember of carbon and oxygen, the bared core of the star, which will then cool, slowly, quietly, for trillions of years. This is the road our own Sun will travel in the distant future. Not an explosion. A swelling, a soft exhale, and then a long, calm cooling. And then there are the heavy stars, the giants, the ones many times the mass of the Sun, the ones like Betelgeuse. These build heavier and heavier elements in their cores, layer upon layer, the way the rings of a great tree record its years, helium giving way to carbon, carbon to still heavier things, each new layer settling beneath the last. They build and build, until at last their core grows past a critical mass that it can no longer hold up against the crush of its own gravity. And then, in seconds, the core collapses, and the star ends as a supernova. It is worth describing that ending plainly and softly, because it is genuinely one of the most beautiful events in all of nature, and because there is nothing in it to fear from this distance. When the core of a massive star can no longer support its own weight, it falls inward, catastrophically, in only moments, faster than thought. That collapse crushes electrons and protons together into neutrons, and in doing so, it releases an immense flood of the faintest, most ghostly particles there are, particles called neutrinos, so reluctant to interact with anything that they pour straight out through the entire body of the dying star and into space, carrying energy away. The crushed core rebounds violently, and a tremendous shock wave tears outward through the star, blowing its outer layers across light years of space, scattering the substance of the star into the dark. And in the heat and pressure of that explosion, something quiet and important happens. The heaviest elements are forged. The gold, the lead, the uranium, all the heavy substance of the universe, made in those final blazing moments, in a furnace that exists nowhere else, and then scattered outward into the dark. The expanding cloud of debris cools over ages and disperses and drifts, a slow, expanding nebula of glowing gas. And in time, gravity gathers it again, the way it always does, the way it gathered the first cold cloud, and shapes it into new stars and new worlds. The matter is not lost. It is only passed on, handed forward, made into something else. This is one of the gentlest truths the stars have to offer, and it is worth resting on it. The atoms in your own hands were forged this way, long ago, in the cores and the death throes of stars that ended before the sun was born. The iron in your blood, the calcium in your bones, the oxygen you are breathing in slowly even now, all of it was made inside stars and scattered by their endings, and gathered again, patiently, over billions of years, into the cloud that became the sun and the earth, and, in time, into you. You are not separate from this story of stars living and ending. You are made of its leftovers. You are, quite literally, gathered starlight, resting for a while in the shape of a person. And the supergiant we are standing near tonight will one day add its own substance to that same long, quiet recycling, scattering the makings of future worlds out into the dark. And at the center, where the great star once stood, there remains a tiny and extraordinarily dense remnant. A neutron star, a city-sized sphere holding more mass than the sun, so dense that a single small spoonful of it would weigh more than a mountain. Some neutron stars spin, swiftly and steadily, sweeping beams of energy around like the slow turning of a lighthouse, keeping a rhythm so precise it could almost be a clock. Or, if the original star was heavy enough, the core falls further still, past even that, and becomes a black hole. And the very heaviest stars of all may be torn apart so completely by the blast that they leave no remnant at all, only scattered matter and light spreading outward forever, the whole substance of the star given entirely back to the dark. Betelgeuse will end this way. It will end as a supernova, possibly within the next 100,000 years, which is soon in the slow language of the stars, though no one can name the day or the century or even the era with any certainty. When it goes, it may shine briefly in Earth's sky as bright as the full moon, a single dominant point of light, holding the night, visible even in daytime for a while, and then slowly, over weeks and months, fading. Most likely, it will leave a neutron star behind, a tiny spinning remnant where the giant once stood. If it is heavier than we currently believe, it may leave a black hole instead. And here is the thing to hold on to, gently, before we move on. Betelgeuse is no danger to us. It is far enough away that its eventual explosion poses no threat to the Earth at all. The burst of radiation that accompanies the supernova will not harm us, will spread and thin across the great distance until it is only a light to look at, The physical debris, the scattered matter of the star, would take millions of years even to drift near the solar system, slowing and thinning and dispersing across all that time, gentled by distance, long before it ever arrived, and turned aside in any case by the sun's own outward wind. The death of a great star, watched from here, is simply a light in the sky. It is a quiet and beautiful thing to witness, a slow and grand event, not a thing to fear. We can rest beside a dying giant and feel only wonder, and then drift on into the dark. Part 4. The Rogue Planets. We turn now towards some of the loneliest things in the whole of the galaxy. Until this point in our journey, almost everything we have visited has belonged to something. The planets belonged to their stars. The stars belong to the slow wheel of the galaxy. Even the outbound probes are still, in a sense, leaving a place they once belonged to, trailing a thread back toward home. But the worlds we are drifting toward now belong to nothing at all. They are planets with no star, and they move through the great dark entirely on their own. These are the rogue planets. They are also called orphan planets, or nomad planets, or free-floating planets, and each of those names tries to hold the same quiet idea, turning it gently in a different light. A rogue planet is a world that is not orbiting any star. It is not lit by any sun. It has no day, no year, no warm point of light to circle. It simply travels, freely, through the long space between the stars, bound to nothing, falling toward nothing, drifting through the night at the pace the galaxy set for it long ago. They are extraordinarily difficult to find, and it is easy to understand why. A planet with no star shines almost no visible light of its own. There is nothing for it to reflect, and it is far too cool to glow. There is simply nothing in ordinary light to catch it by. The warmest of them can sometimes be glimpsed by infrared telescopes, the kind of instruments that sense faint heat rather than visible light, because a rogue planet may still carry a gentle warmth of its own, a soft inner glow in the long wavelengths. Others are caught only in a brief and passing moment, when one happens to drift directly between us and a distant star, and bends that star's light for a little while, a fleeting flicker that betrays an unseen mass. Because they hide so well, only a small number of objects can be confidently called rogue planets, with a few dozen further candidates still being studied and weighed. And yet the careful counting, the patient statistical work, suggests something staggering. The Milky Way may hold an enormous number of these starless worlds, possibly billions of them, perhaps as many as there are stars, or even more. The galaxy may be quietly full of them, a great hidden population, drifting unseen between the bright and visible stars. We are, very likely, only at the very beginning of finding them, only at the first page of a long discovery. There is even a soft disagreement about what to call them, and the disagreement is itself rather lovely, the kind of gentle uncertainty that suits a thing so newly known. Some who study these objects look at the larger ones and see not true planets, but failed stars, bodies that gathered enough material to begin warming, but never quite enough to ignite, never quite enough to cross the threshold into starlight. And a broader word is sometimes used, a quiet umbrella term, that simply describes any starless interstellar body that never lit its inner fire. The naming is unfinished. The categories blur into one another at their edges. The objects themselves, of course, do not mind in the least what we decide to call them. They simply drift. How does a planet come to live without a star? There are two main paths to such a life, and they can be told as two quiet origin stories, two different beginnings for the same dark and patient ending. The first path is the path of being thrown out. A planet forms in the ordinary way, in the swirling disk of gas and dust around a young star, settling into its orbit, taking its place among its siblings, becoming, for a time, an ordinary world with an ordinary sun. And then, somehow, it is cast out. The gravity of a larger sibling planet can fling it outward, a single close encounter giving it more speed than the star can hold. A close pass by another star can tug it loose from its orbit. A collision or a great disturbance between two whole planetary systems can scatter worlds like seeds thrown to the wind. However it happens, the planet is thrown free of the star that made it, and it drifts away, slowly, into the dark, alone, carrying with it whatever warmth and air and water it had when it left. The second path is gentler, and stranger, and quieter. It is the path of being born alone. A small cloud of interstellar gas collapses inward under its own gravity, exactly the way a star is born, exactly the way Betelgeuse was born, the way the sun was born. But this particular cloud holds too little material. It draws together, and it warms, and its center grows dense, but it never gathers quite enough mass to ignite the fusion that would make it shine. And so what forms is not a star at all, but a planet-sized body that was never bound to any star, that has been solitary from its very first moment, that never had a sun to lose. We can pause our drift beside the nearest confirmed rogue planet that we know of, a cold and dark world, a little over 7 light-years from the Sunday. It was found by an infrared telescope, sensed by its faint heat, because it gives off almost no visible light at all, nothing the eye or an ordinary telescope could catch. It is extremely cold, far below the freezing point of water, cold enough that it resembles a cooled-down gas giant more than a rocky world. It carries several times the mass of Jupiter, and it is at least 1 billion years old, which means it has been drifting, dark and starless, for longer than there has been complex life on Earth. It is made largely of hydrogen, and there is something quietly wonderful about it. There is evidence of water in its atmosphere, water gathered into clouds of fine ice particles, drifting and shifting in its dark and frigid air. It may be the only world we know of, anywhere outside our own solar system, that carries clouds of water ice, a starless world with weather, with clouds, drifting silently through the night. It is worth resting, here, on what a rogue world is actually like, because the first thought is bleak and the truth is warmer than the first thought, and the difference between them is one of the gentle surprises of this whole journey. At first, imagining a rogue planet seems the most desolate place that could exist. A world with no sun. No day, no dawn, no seasons, no shifting light at all. Wrapped in a darkness that never lifts and never will. And yet the science tells a softer story than that first bleak imagining. With no star to warm it, the only heat a rogue planet has comes from within. There is the warmth left over from its formation, the slow heat of its own long ago making, still seeping outward after all this time. And there is the heat released, steadily and patiently, by radioactive elements decaying far inside it, a slow and quiet inner fire. This is the same inner warmth that drives the geology of our own Earth, the same warmth that stirs beneath your feet right now, that moves the continents and lifts the mountains. A rogue planet carries that warmth with it, into the dark, a small hearth of its own that no distance from any star can put out. And a thick atmosphere can hold that inner warmth remarkably well. A dense blanket of hydrogen wrapped around a planet traps heat the way a heavy quilt traps it on a cold night, holding the warmth in rather than letting it escape to the sky. Even a thick layer of ice across the surface can do the same, sealing the warmth beneath it. And so, a rogue planet, drifting starless through the night, may not be frozen solid all the way through at all. Some of these worlds may hold oceans of liquid water beneath a crust of ice, dark hidden seas warmed from below by the planet's own slow inner fire, sealed from above by its own cold protecting shell, holding that quiet ocean steady for billions of years. A sea with no sky, in the dark, kept liquid by the planet's own warmth. A rogue planet need not even be entirely alone. A world thrown out of its system may carry a moon with it, flung free at its side, the two of them keeping each other company as they drift. Two rogue worlds may travel together as a bound pair, circling one another, a small companionship in the wide dark. And a more massive rogue may hold a small family of moons of its own, a tiny system with no sun at its center, the moons circling the dark planet the way planets circle a star. The gentle tidal flexing between a rogue world and a moon, the slow stretching and easing as they pull on one another, could add still more warmth to both. So even the loneliest objects in the galaxy are not always quite as lonely as they first seem. Even out here, in the starless dark, there is companionship, and there is warmth, and there is the quiet keeping of company. There is a soft and wondering thought to voice here, gently, and then to let go of, the way you might pick up a smooth stone, turn it over once, and set it down again. A starless world, with a warm interior and a hidden ocean beneath its ice, is not, in principle, a place where simple life would be impossible. This is not a claim. It is only a quiet, open speculation, the kind that suits a calm and drifting hour. Somewhere out in the great dark, a wandering world with no sun in its sky might still hold, beneath its frozen crust, in its hidden and lightless sea, something slow and warm and alive, something that has never known a star and never missed one. We do not know. We may never know. But the dark is wide enough and generous enough to hold the possibility. It helps, too, to picture the surface of such a world, gently, just for a moment. The sky of a rogue planet would not be empty. It would have no sun, and so no blue day, no glare, no warmth falling from above. But it would have stars, the full soft scatter of them, undimmed by any daylight, turning slowly overhead as the world turned. A rogue planet has the darkest and clearest night sky there could ever be. An unbroken night that never gives way to morning, with the whole quiet galaxy spread across it. And below that endless starlit sky, the world itself would be still and cold at its surface, and yet warm far down, holding its hidden sea, keeping its own slow inner weather. It is a strange picture, and a peaceful one. A dark world under a sky full of stars, drifting, holding its warmth close, asking nothing of anyone. Most of what we understand about rogue planets has come from careful mathematical modeling, built up patiently from the tiniest scraps of telescope data, from faint hints and brief flickers, and the slow work of calculation. But that is changing, and changing soon. Survey missions are being designed now, deliberately, specifically, to hunt for these free-floating worlds, to watch for the brief, telltale brightening that happens when a dark body drifts precisely between the Earth and a distant star and bends its light. The coming years will likely turn the rogue planets from a nearly theoretical idea, a thing known mostly by inference, into a charted and counted population of the galaxy, a real census of the wanderers. And what becomes of a starless world in the end? In principle, a rogue planet could one day be caught by the gravity of a passing star, and gain a home, and become part of a new system, and have a sun again. But that chance is vanishingly small, a rare accident in an enormous and mostly empty dark. Far more likely, a rogue planet simply drifts for billions of years, cooling slowly, gently, keeping its own quiet company in the night. Some will eventually fall toward black holes. Some will be scattered by chance encounters into new directions. Most will simply continue, dark and patient and untroubled, long after the stars around them have lived and changed and ended. And that is the gentle truth to carry away from this part of the journey, the soft thing to hold as we drift on. To be alone out here is not a tragedy. A rogue planet is not missing anything. It is not waiting for a star. It is not lost. It is simply doing what planets do, on its own, in the dark, turning slowly, holding its warmth, and its solitude is not an emptiness, but a kind of completeness. There is real rest in that image, real quiet. A warm world, calm and whole and untroubled, moving alone through the long and gentle night, needing nothing, asking nothing, in no hurry at all, going on and on. We can leave the rogue planets to their patient drifting and travel on ourselves. Part 5. Beyond the Milky Way. We make our largest leap yet, now. Until this moment, every place we have visited, every star and every starless world has been part of our own galaxy, the Milky Way. The probes, the nearby stars, the dying giant, the rogue planets, all of it has been near home, all of it within the one great wheel of stars we belong to, all of it still, in a sense, in the same room. Now we step outside that wheel entirely. We rise above our own galaxy and look back at it from without, the way you might step outside a house at night and turn to see its shape against the sky. And then we drift onward, to the nearest galaxies beyond. It helps to begin with galaxies in general, softly, before we visit any single one. There are more galaxies in the universe than anyone can count with real certainty. The estimates run well past several 100 billion of them, and that is only the part we can see. Each one is an enormous gathering of stars, held together by gravity, turning slowly in the dark. They come in a few main shapes. Some are smooth and rounded, the elliptical galaxies, like soft glowing eggs of light. Some are graceful spirals, with bright arms of stars winding outward from a glowing center, and our own is one of these. Some are shaped like a lens, and some are irregular, with no neat form at all, just a soft scatter of light. And their sizes span an enormous range, from small dwarf galaxies holding only a few 100,000 stars worth of mass, faint and modest, up to giant ellipticals more than 1,000 times the mass of our own Milky Way, enormous and ancient and slow. Before we leave it behind, let us look back at our own galaxy, not as home, but simply as one object among the many, the way a traveler might. The Milky Way is a barred spiral galaxy. It is a great flattened disk of stars, perhaps 100,000 light-years or more across, and yet only about 1,000 light-years thick, an enormous thin plate of light turning slowly in space, with a soft straight bar of stars across its middle, and arms winding out from the ends of that bar. At its center, there is a rounded bulge, a few thousand light-years thick, where the stars crowd close and old. It holds somewhere between 200 and 400 billion stars, along with a great many faint, dim brown dwarfs that began to form, but never quite became stars at all, never quite lit. Far down at the center of the Milky Way, hidden within that bulge, there lies a supermassive black hole, a quiet, enormous mass roughly 4 million times the weight of the Sunday. We will come to black holes soon, and so we only nod to it here, the quiet anchor at the galaxy's center. And there is something else, something most of the galaxy is actually made of, that we cannot see at all, in any light, by any instrument. Most of the Milky Way's mass is not its stars. It is dark matter, an unseen substance whose presence is felt only through its gravity, an enormous invisible halo cradling the bright disk we can see, holding it, shaping its slow turning. Counting that dark matter in, the whole galaxy may weigh well over 1 trillion times the mass of the Sunday. And our own Sun, with all its planets, with the Earth and everyone on it, sits far out from the center, in a minor spiral arm, neither central nor special nor singled out. Simply one star, in a quiet outer part of the disk, in the slow turning of an enormous wheel. The Milky Way does not stand alone in the dark. It belongs to a small, gravitationally bound family of galaxies, a gathering we call the local group. There are over 50 galaxies in that family, spread across a region of space roughly 10 million light-years wide, with a combined weight of a few trillion suns. Most of those 50 are small dwarf galaxies, faint and modest, the quiet members of the family. Only 3 of them are large. And we will visit each of the 3, gently, in turn, the way you might be introduced to the 3 eldest members of a household. But first, close around our own galaxy, there are the satellites. Several dozen small galaxies orbit the Milky Way, drawn along by its gravity, most of them faint, irregular dwarfs, and many of them twisted and bent out of their original shape by the steady, patient pull of our galaxy. The largest of these companions is a small galaxy holding tens of billions of stars, only a fraction of the Milky Way's size and weight, partly because it has no central supermassive black hole anchoring it, no great mass at its center. And yet, within that one small companion galaxy, there are genuine record holders, waiting, quietly. There is a stellar nursery there that is home to one of the heaviest stars ever found anywhere, a blazing blue supergiant, hundreds of times the mass of the Sun, a star near the very upper limit of how massive a star can be. And there is one of the largest stars known by sheer volume, a red giant whose width is over 1,000 times the diameter of the Sun, a star so enormous it strains the imagination just as Betelgeuse did. Some of the Milky Way's smaller satellites are being slowly torn apart by our galaxy's gravity, their stars stripped away gently over long ages and drawn out into long, faint streams that loop and trail around the Milky Way like pale ribbons, the slow unraveling of small galaxies into our larger one. The nearest large galaxy to our own is Andromeda. It lies about 2.5 million light-years away, which makes it the most distant single thing that most people can ever see with their own eyes alone, on a clear and moonless night, far from any city light. A faint and elongated smudge of soft glowing light, low and quiet in the dark. And when you see it, you are seeing light that left that galaxy 2.5 million years ago, light older than our whole species, only now arriving. Andromeda is a spiral galaxy, somewhat larger across than the Milky Way, and it is home to perhaps 1 trillion stars, several times the count of our own galaxy. And yet, curiously, despite holding so many more stars, its total mass is roughly the same as the Milky Way's, because its stars are, on average, older and lighter and gentler than ours, a population a little further along in its long life. Andromeda has a strange and lovely feature at its center. Seen through a telescope, it appears to have a double core, 2 bright concentrations of light close together near its middle, as though the galaxy had 2 hearts. The most likely explanation is quiet and subtle and rather beautiful. It is probably a single off-center ring of stars circling the galaxy's central black hole, seen at such an angle that one side of the ring, where the stars linger a little longer, looks brighter than the other, giving the soft illusion of 2 separate cores where there is really one ring. Andromeda is also far richer than the Milky Way in globular clusters, those dense and ancient balls of hundreds of thousands of stars, and many of those clusters are likely the surviving cores of smaller galaxies that Andromeda absorbed long ago in its slow, patient growth, the lasting hearts of galaxies that are otherwise long gone. The Milky Way and Andromeda are drawing slowly toward one another, across the gulf between them. And in billions of years, far beyond any horizon a person need think about tonight, the two great galaxies may merge, gently, into a single larger galaxy. It is worth holding that softly, because it is easy to imagine it wrongly. It is not really a collision, not in the way the word suggests. The stars within each galaxy are so far apart from one another, separated by such wide emptiness, that almost none of them would ever strike another. It is more a slow joining, a long and graceful settling together of two great wheels of light into one, a merging measured in billions of years, far too slow and far too distant to be any cause for unease on a quiet evening. The third large member of our local group is the Triangulum Galaxy, a spiral roughly half the size of the Milky Way, with no confirmed central supermassive black hole of its own, a quieter and smaller wheel of stars. Triangulum holds one of the largest known stellar nurseries anywhere, an enormous region over 1,000 light-years across, where hundreds of hot young supergiant stars blaze inside great glowing clouds of gas, their fierce light setting the gas alight, making the whole region shine. And beyond those three large galaxies, the rest of the local group is filled out with scattered dwarf galaxies, some bound loosely to the big spirals, drawn along in their company, and some drifting more freely on their own, including one small galaxy that is, unusually, still busily making new stars, still lit with the work of creation. And the local group is itself only a small piece of something far larger. We can sketch the widening rooms quickly here, lightly, and save the true, full feeling of scale for a little later in our journey. The local group sits within a flattened sheet of galaxies, and that sheet is part of an immense structure called the Virgo supercluster, spanning over 100 million light-years and holding tens of thousands of galaxies. And that supercluster is itself only part of a still greater assembly, sometimes called Laniakea, a supercluster of superclusters some 500 million light-years across, a structure so large that the Virgo supercluster is only one of its limbs. At the center of these slow flows of galaxies lies the Great Attractor, a gravitational focus drawing galaxies gently toward it, and one we cannot even see directly, because the crowded disk of our own Milky Way lies in the way and blocks the view. Its exact nature is still an open and quiet puzzle, one of the things the universe has not yet told us. And on the very largest scale of all, the galaxies are not scattered evenly through space, the way you might first imagine. They are gathered. They are strung along immense filaments and walls, drawn into long, bright threads and broad sheets, and separated by immense and nearly empty voids, enormous rounded regions of dark with almost nothing in them. Astronomers call this great pattern the cosmic web, and that is a good name for it, because it does look like a web, a slow web of light spun across the whole universe. Some of its walls of galaxies stretch for billions of light-years, structures so enormous that their very existence is a soft and gentle challenge to our understanding of how the universe grew, things almost too large for our models to have expected. It is worth lingering for a soft moment on those voids, because they are easy to imagine as something sad and are really something quite peaceful. A void is not a wound in the universe. It is not an absence of something that should be there. It is simply a region where the slow gathering of matter ran the other way, where gravity, over the long ages, drew the galaxies outward toward the surrounding filaments rather than inward, leaving the middle gently emptied. The voids are the quiet rooms of the cosmos. They are spacious and dim and calm, and they are, by volume, most of the universe. If you could drift through the center of one, the nearest galaxies would be so far away that the sky would seem almost wholly dark. There is a stillness to that thought, rather than a loneliness. The universe has made itself room to breathe. And the whole cosmic web, all of it, the bright filaments and the broad walls and the long dark voids, did not begin this grand. It grew. In the early universe, the matter was spread very nearly smooth, with only the faintest, gentlest unevenness, slight thickenings and slight thinnings, barely there at all. But gravity is patient, and gravity always works the same way. The slightly denser places pulled in a little more, and grew a little denser still, and pulled in more again, while the slightly emptier places gave their matter up and grew emptier. Across billions of years, that faint early unevenness was drawn out, slowly, into the great and intricate web we drift through now. The grand structure of everything is simply a small early whisper, grown patient and large. This is the note to carry onward from here. Every single step we have taken outward has revealed not emptiness, but more. The galaxy opened into a group. The group opened into a supercluster. The supercluster opened into the cosmic web. And the walls never slam shut. They simply widen, quietly, gently, onto a larger room, and then a larger room again, on and on. Vastness, on this journey, is a gentle thing, not a frightening one. The universe is roomy, not crowded. It is spacious, and it is calm, and there is always, always more room ahead. Part 6. The Black Holes. We turn now toward the strangest objects our journey will meet. They are places where matter has fallen so far inward, and gathered so tightly, and crowded so completely upon itself, that gravity has overwhelmed every other force, and a region has formed from which nothing at all can return. Not even light. These are the black holes. We have brushed past them already, gently, as the remnants left behind by the heaviest dying stars, the final state of a giant like Betelgeuse. Now we let them become the subject itself, and we drift among them softly, because a black hole is very easy to make frightening, and we are going to do the opposite tonight. We are going to find the stillness in them. A black hole forms when matter is compressed so densely that its own gravity becomes overwhelming, stronger than anything that could push back against it, and around it there forms a region from which nothing can escape. The edge of that region has a name. It is called the event horizon. It is a boundary of no return, a soft and invisible line drawn in empty space, and its size depends only on one single thing, on how much mass the black hole holds. A heavier black hole has a wider horizon. A lighter one has a smaller horizon. Cross that line inward, and there is no path back out, no direction that leads away. But the line itself is quiet. It does not glow. It does not roar or churn. It is simply a place in space past which return is no longer possible, and it waits, and it is still. Black holes are genuinely hard to find, precisely because they give off no light of their own, nothing to see them by. Only a modest number of them have been confidently identified across the whole sky. And yet careful mathematical modeling suggests that our Milky Way alone may hold 100 million of them, scattered quietly through the galaxy. That sounds, at first, like an enormous and crowded multitude. But set it against the 200 to 400 billion stars of the galaxy, and the truth of it softens. For every black hole, there are thousands upon thousands of ordinary stars. Black holes are, in fact, rare, and widely spaced and quiet. They are not lurking around every corner of the dark, not waiting anywhere near us. They are simply, here and there, scattered thinly, part of the quiet furniture of the galaxy. We can pause beside one of the closest black holes we know of. It is part of a pair, a binary system a few thousand light-years away, in which an ordinary orange dwarf star traces a tight little orbit around an unseen companion, completing a full circuit every few hours, swinging around again and again. The companion gives off no light at all. There is, by every ordinary measure, nothing there. And yet it is clearly heavy, and it is far too massive to be a neutron star, too heavy for that gentler kind of stellar remnant. And so the quiet conclusion, the only one that fits, is that it is a black hole. The orange dwarf is being slowly stretched by its companion's gravity, gently pulled out of round, and a thin stream of its gas is being drawn away from it, spiraling inward toward the unseen mass. As that gas falls inward, it crowds and heats, and forms a hot and brilliant disk, glowing fiercely as it spirals down. And it is the glow of that disk, not the black hole itself, that tells us the black hole is there at all. We do not see the darkness. We see the light of what is falling toward it. It is worth pausing, too, on the strange and gentle thing that a black hole does to time and to space around it, because it is one of the quietest wonders in all of physics. Close to a black hole, gravity is so strong that it slows the passing of time itself. Not in any way that would feel strange to someone there, for whom a second would always feel like a second. But to a distant watcher, looking on from far away, a clock near the event horizon would appear to tick more and more slowly the closer it drew to the edge. If you could watch something fall toward a black hole, you would see it slow, and seem almost to pause at the very horizon, its motion stretching out, its light dimming and reddening gently, until it faded softly from view, rather than vanishing all at once. There is no violence in that picture, watched from a distance. There is only a slowing and a reddening and a quiet fading, like a thing easing into sleep. It is worth taking a calm moment, here, to undo the most common misunderstanding about these objects, because the misunderstanding makes them frightening, and the truth makes them peaceful. A black hole does not roam through space, sucking everything in, pulling in worlds and stars from far away. That is simply not how it behaves. Seen from a distance, a black hole's gravity behaves exactly like the gravity of any ordinary object of the very same mass. There is nothing extra, nothing reaching, nothing hungry about it. If our own sun were somehow replaced, in an instant, by a black hole of equal mass, the planets would not be pulled in. The Earth would not fall. The planets would carry on in their orbits, exactly as before, undisturbed, tracing the same slow paths. Only colder and darker, with no warm light at the center. The black hole would simply sit where the sun had been, holding the same gentle place, with the same gentle pull, and the worlds would keep circling it as if nothing at all had changed. There is one more soft idea worth holding before we move on, and it concerns the supermassive black hole at the center of our own Milky Way. It weighs around 4 million times the mass of the Sun, and it sits, calm and quiet, at the very center of the galaxy, the still point of the great turning wheel. But it is, for the most part, gentle. It is not feeding vigorously. It is not a blazing quasar. It is a quiet giant, mostly resting, and the stars near it, including a few that orbit surprisingly close, trace their long curving paths around it in peace, year after year, age after age. Everything you have ever known, every person, every story, every quiet evening, has been carried in a slow circle around that distant dark center once every couple of 100 million years. We are, all of us, in a gentle orbit around a stillness we will never see. There is something steadying in that. The center of our galaxy holds, and we turn around it, and it has held us so faithfully for the whole long age of the Sunday. And because their gravity is so ordinary at a distance, black holes can hold stable planetary systems, just as stars can. This is one of the quietly beautiful facts of the universe. Worlds can form in the disk of debris left behind by the very supernova that made the black hole. Worlds can be captured from a system the black hole has drifted near. Even a wandering rogue planet could, in principle, be caught into a quiet orbit around one. The radiation from a black hole's accretion disk could even warm such worlds, give them a kind of light and heat. It is a strange and softly beautiful idea. A planet with a sky, with weather, with a horizon, orbiting a darkness, turning patiently around a center that gives off no light of its own. And it is exactly the kind of gentle wonder this whole journey is made of. Exactly the sort of thing the dark turns out to hold once you look at it without fear. There are thought to be three main kinds of black hole in the universe, and they differ above all in their mass. The first kind are the supermassive ones, the great quiet masses that sit at the centers of most large galaxies, including our own, weighing millions to billions of times the mass of the Sunday. They grow over enormous stretches of cosmic time by slowly drawing in gas and by merging with one another when galaxies merge. And when such a black hole feeds vigorously, when a great deal of material is spiraling into it at once, the disk of matter swirling around it can blaze so brightly that it shines across billions of light years, outshining the entire galaxy around it. In that bright and feeding state, it has a name of its own. It is called a quasar, a beacon of light visible from almost the edge of everything, the brilliant sign of a feeding giant. The second kind are the stellar mass black holes. These are the far more numerous remnants of the heaviest dying stars, the kind Betelgeuse will one day leave behind, weighing only a few times the mass of the Sunday. They are harder to detect, being small and dark and scattered, but they are everywhere, threaded quietly through every galaxy. And when two of them spiral together and at last merge into one, they send ripples, spreading outward through the very fabric of space itself, gentle waves in the shape of the universe, called gravitational waves, a kind of soft tremor in space passing outward from the meeting, carrying the news of it across the cosmos. The third kind are still only hypothetical, a maybe rather than a certainty. They are called primordial black holes, and they may have formed not from any star at all, but from dense ripples in the matter of the very early universe, in its first young moments, when everything was crowded close. None has ever been confirmed. The smallest of them, if they exist, would slowly evaporate over enormous and almost unimaginable stretches of cosmic time, growing gradually fainter and warmer until they ended, at last, in a final quiet flash. But no such flash has yet been seen anywhere. They remain a soft and open maybe, a door not quite opened, a possibility the universe has neither confirmed nor closed. Since a black hole gives off no light, finding one is always a patient and indirect art, a kind of quiet detective work. There is a gentle toolkit for it, a handful of ways. One way is to watch a companion star, to notice a star tracing a tight little orbit around something invisible and heavy, betraying its unseen partner simply by the shape of its own circling dance. Another way is to watch for the glow of an accretion disk, the brilliant telltale signature of gas heating and shining as it falls inward. With great care and great effort, the very silhouette of a black hole can even be photographed, its dark, round shadow caught and held against the bright disk of light that surrounds it. And a black hole can also be found by gravitational lensing, by the way its mass bends and briefly brightens the light of a more distant star as it drifts slowly in front of it. There may also be black holes that no method has yet caught, and it is gentle to think of them too. There may be wandering black holes, drifting alone through the spaces between the stars, without any companion star to betray them, without any disk of gas to glow around them, simply moving, dark and quiet, through the dark. If one passed through an empty region, far from anything bright, there would be almost no way to know. It would give off no light. It would bend the light of distant stars only faintly, only now and then. It would simply travel, unseen, the way a rogue planet travels unseen, a small piece of stilled and gathered matter moving through the long night. There is no need to find such an idea unsettling. A wandering black hole is not seeking anything. It is only drifting, like so much else in this journey, patient and quiet, and in no hurry, one more soft and shy traveler in the dark. And here is the gentle truth to carry away from the black holes, the soft thing to hold as we move on toward the edge of everything. A black hole is not a monster. It is not a mouth, not a hunger, not a thing that hunts. It is a center of stillness. It is the place where motion finally comes to rest, the quiet weight around which a whole galaxy turns, slowly, patiently, for billions of years. There is something deeply restful in that image, when you let it settle fully in the mind. A darkness that does not chase anything. A darkness that does not roam, or seek, or want. It simply holds its place, calm and patient and unmoving, at the center of things, and lets everything else circle gently around it. At the very center of a galaxy, the black hole may be the most peaceful thing in the whole of the sky. Part 7. The Edge of the Observable Universe. We come now to the longest reach of our whole journey. We are going to travel as far as it is possible to travel, all the way to the boundary of everything that can be seen. Let the drift slow here, gentle and unhurried. We are approaching the largest single idea of the night, the widest thought we will hold, and it deserves a slow and easy pace, the way you would walk the last stretch of a long path, in no rush to arrive. It helps to remember the ladder we have climbed to get here, to look back down it once before we take the final step. We began beside the small outbound probes, at the edge of the sun's own breathing bubble. We crossed to the nearby stars, and visited a handful of them not as points of light, but as places. We paused a long while beside a dying giant, and learned, gently, the whole story of how stars live and end. We drifted among the starless rogue planets and found warmth even there. We rose above the Milky Way and found it was only one galaxy in a local group of 50, and the local group only one piece of an immense supercluster, and the supercluster only one strand of the great cosmic web. Each room, as we entered it, opened onto a wider room beyond. And now, we take the final step. Beyond the largest structures of the cosmic web, beyond the longest filaments, and the broadest walls, and the deepest voids, there lies the edge of the observable universe itself. To understand that edge, we have to understand a gentle and surprising fact, one that takes a moment to settle into. Space itself is expanding. The universe is not a still and finished room. It is, very slowly, growing. Every distant region of it is steadily moving away from every other region, and the farther apart any two regions already are, the faster the distance between them grows. This is not the motion of things traveling through space, the way a probe travels, or a comet, or a thrown stone. It is space itself quietly, everywhere, stretching, carrying everything within it gently along, the way a slow-rising tide lifts every boat in a harbor at once, without any boat needing to move. And because that expansion is the stretching of space itself, and not the motion of objects through space, something follows from it, softly and inevitably. Ordinary motion through space has a limit, a ceiling, a fastest possible speed. But the stretching of space is not motion of that kind, and so it is not bound by that ceiling. This means there is a distance, far out in the dark, beyond which whole regions of the universe are receding from us, faster than their light could ever cross the widening gap between us. Their light is, in a gentle sense, traveling toward us up a road that is itself lengthening faster than the light can walk it. And so that light, however long it travels, will never quite arrive. Those regions are not hidden behind anything. They are simply, quietly, beyond reach. This creates a horizon. Not a wall, not an edge of anything solid, nothing you could ever strike or touch, but a horizon, a limit of view, the way the curve of the earth makes a horizon on a calm sea. We can see, and we can ever interact with, only that part of the universe whose light has had time, across the whole long history of the cosmos, to reach us. And that visible region forms an enormous sphere, with us at its center, a sphere roughly 93 billion light-years across. It is sometimes given a name of its own, the metagalaxy. It is everything we can, even in principle, ever see, the whole of our possible view. At the very farthest edge of that sphere, our journey reaches the most ancient light there is. It is a faint and even glow, and it comes from every direction at once, all across the sky, the same gentle whisper of light, no matter where you look. It is the relic radiation left over from the time, long ago, near the very beginning, when the young cosmos first cooled enough to become clear, to become transparent, and let its light travel freely for the first time. Before that moment, the universe was a glowing fog. After it, the fog cleared, and the light it released has been traveling ever since, stretched and softened by all the expansion of all the ages, until now it is only a faint and gentle glow. It is the closest thing the universe has to a visible wall. But it is not a wall of matter, nothing solid. It is a wall of time. It is simply the oldest light that has had any chance, in all the long ages, to arrive here and be seen. It is worth resting on that ancient light for a moment longer, because it is gentler and stranger than it first sounds. When it first set out, near the beginning, it was a fierce and brilliant glow, the light of a young and glowing cosmos. But the expansion of space, working on it across all the billions of years of its long travel, has stretched it slowly, wave by wave, softening it, cooling it, until what arrives here now is no longer brilliant at all. It arrives as a whisper, a faint warmth spread evenly across the whole sky, only a few degrees above the coldest cold there is. The most ancient light in the universe reaches us not as a blaze, but as the softest possible glow, a glow you could never see with your eyes, only sense with patient instruments. The universe's oldest message, after the longest journey there is, arrives gentled almost to silence. There is something quietly fitting in that the first light should reach the present so softly, and that even glow is not perfectly smooth. Across it, very faintly, there are the gentlest of variations, places very slightly warmer and places very slightly cooler, a soft and subtle pattern spread across the whole sky. Those tiny variations are precious. They are the early unevenness of the universe, the faint thickenings and thinnings of matter, set down near the very beginning. They are the seeds. Every filament of the cosmic web, every wall of galaxies, every galaxy and every star, and every quiet world we have visited tonight, all of it grew, patiently, over billions of years, from those faint, soft ripples in the oldest light. The whole grand structure of everything was written, very gently, into that first glow. And it is important to be clear, gently, about what this edge is and what it is not, because the two are easy to confuse. The edge of the observable universe is not the edge of the universe. It is only the edge of our view of it. It is the limit of what light can have reached us, not the limit of what exists out there. The wider universe almost certainly continues, far past that horizon, on and on. It may be hundreds of times larger than the part we can see. It may, for all anyone knows, have no end at all, no edge anywhere. We simply cannot see those further reaches, not because anything stops there, but because their light has not yet had time to come to us. And there is no special place in any of this, no true center and no true rim. Every observer, anywhere in the entire cosmos, on any world, in any galaxy, sits at the center of their own observable sphere, with their own horizon at their own 93 billion light-years in every direction. There is no center of the universe to stand at, and no edge of it to fall off. There is only, for each watcher, their own gentle circle of sight, the same in every direction, their own soft horizon. We are at the center of ours simply because it is ours. Everyone, everywhere, is at the center of theirs. It is worth letting that idea settle slowly, because it is gentler than it first sounds. To be at the center of your own observable universe is not a claim of importance. It is simply the natural shape of looking out from anywhere. Imagine standing in the middle of a wide and gentle fog. In every direction, the fog fades the view at the same distance, and so you seem to stand at the center of a soft grey sphere. But everyone standing anywhere in that fog feels exactly the same, each at the center of their own. The fog has no center. There are only countless gentle spheres of sight, overlapping, each one belonging to a different watcher. The universe is like that, not crowded around any one point, simply seen, softly, from wherever a watcher happens to be, with the view fading kindly at the same distance all around. And there is a quiet beauty in what that fading actually means. To look far out into space is always, unavoidably, to look back into time. The light from a nearby star left it years ago. The light from a distant galaxy left it millions of years ago. And the light from the farthest reaches left when the universe itself was young. So the great sphere of the observable universe is not only a map of space. It is a map of the past, arranged in soft shells, the near things showing us their recent selves and the far things showing us their ancient ones. When you look up at the night sky, you are never seeing the present. You are seeing a gentle gathering of different pasts, all arriving at once, all reaching your eye on the same quiet evening. The sky is the universe's long memory, and looking at it is a kind of remembering. As the expansion of space carries on, that horizon will slowly change what it holds. The most distant galaxies will, over enormous and unhurried stretches of time, slip quietly past the edge of view, their light stretched further and further until it fades away into silence, until they can no longer be seen at all. Far in the future, an observer would see only their own settled local family of galaxies, with the deeper universe gone dark and quiet beyond it. But that future is so unimaginably distant, so far beyond any human reckoning, that it is no cause for any unease tonight. It is simply the slow shape of things, told softly, a change measured in spans of time too great and too gentle to trouble a single quiet evening. So picture the arrival now, gently. We do not crash into a barrier. We do not strike an edge or a wall. We simply drift outward and outward until we reach the place where the universe has run out of time to show us anything more, and we find, glowing softly all around us in every single direction, the oldest light there is, the faint, even whisper of the early cosmos. It is less an edge than a horizon. It is the point past which the view fades, not because something has stopped, but because the light from beyond has not yet had time to come. We have reached as far as seeing itself can reach. And it is calm here, at the edge of everything. It is very, very calm. Part 8, Beyond the Edge of Everything. And now we take the last step of all. We move off the map entirely. We drift past the edge of the observable universe, past that soft horizon of ancient and even light, into a country where seeing can no longer follow us, and where all that is left to us is wondering. This final part of the journey is built from real ideas, ideas that those who study the cosmos genuinely turn over carefully in their minds. But they are ideas, not findings. They are open questions, doors the universe has left slightly ajar, and we are simply going to look through them gently for a quiet while, and then let them be and turn for home. It is worth being honest, softly, about where we are standing now. Everything in this part of the journey is speculation. It cannot be tested with the tools we have, and perhaps it never will be by anyone. But it is not idle speculation, not loose or careless guessing. It is the serious kind, the patient wondering of careful minds reaching toward a question that is simply far too large to answer from inside. And the uncertainty of it is not a frustration to be hurried past. It is, in its own quiet way, a comfort. There are questions in this universe so enormous, so far beyond reach, that the only honest response to them is to lie still beneath them, the way you might lie still beneath a sky full of stars, and wonder and feel no need at all to have the answer by morning. There is a soft hint, first, that something does lie beyond our horizon, that the dark past the edge is not simply nothing. Some of the galaxies near the edge of the observable universe appear to drift in ways that our models do not fully predict. There are gentle, unexplained tugs in their motion, slight pulls and leanings that the visible universe alone does not quite account for, small discrepancies in the great slow flow of things. One reading of those motions is quietly remarkable. It is that enormous structures, lying far beyond the edge of everything we can see, are pulling on the matter we can see, that the gravity of an unseen beyond is being faintly felt within our own horizon, a hand we cannot see resting gently on the things we can. This is not certain. It is far from certain. It is only a hint, only a soft and unexplained leaning. But it is a real one, and it suggests, quietly, that the universe past the edge of our view is not empty and not still, that there is more out there, doing something. It is worth saying plainly that hints like this are how almost everything we know was first found. The unseen substance we call dark matter was first noticed as a gentle discrepancy, a pull in the motion of galaxies that the visible stars alone could not explain. The expansion of the universe itself was first glimpsed in the soft reddening of distant galaxy light. Again and again, the universe has told us about the things we cannot see by the way they tug, faintly, on the things we can. So a gentle, unexplained leaning in the motion of the farthest galaxies is not nothing. It is exactly the kind of small, soft clue the cosmos has always used to point, quietly, towards something just past the edge of knowing. we may never follow that particular clue to its end. But it is a real finger, raised in the dark, pointing outward, past the horizon, and saying, gently, there is more. From that hint, the wondering opens outward into a few larger ideas, and we can hold each of them for a moment, lightly, the way you might hold a series of smooth stones, one after another, and then set them down. The simplest idea is also the most likely one. It is that the universe simply continues, past our horizon, much the same as the part we can see, only far larger. More galaxies, more filaments, more of the same gentle cosmic web, the same pattern spreading on and on, possibly vastly farther than we can imagine, possibly without any end at all. In this picture, our observable sphere is nothing special, nothing chosen. It is one ordinary region of a cosmos too enormous ever to be seen whole. We live in a small lit circle within a room that has no visible walls, and the room, in all likelihood, goes on for a very long way. There is a real and quiet comfort in that simplest idea, and it is worth pausing on before the stranger ones. It means the cosmos is not a small or a finished thing. It is not a closed box with us rattling around inside it. It is open and generous and far larger than anything we will ever map. The dark beyond the horizon is not a wall pressing in. It is simply more room, more of the same gentle pattern of light and space, stretching away in every direction, far past any need to reach the end of it. To live in a universe that exceeds your sight by so much is not to be hemmed in. It is to be held inside something enormous and unhurried, with no edge nearby to press against, and a great deal of soft, dark space in which simply to be. A deeper idea wonders whether the universe is even the same everywhere. It imagines that, in regions far beyond our horizon, the fundamental constants of nature themselves might take different values. The strength of the forces, the properties of the particles, the very rules that all the matter follows, all of it might be set differently in some distant region than it is set here. And our own region would simply be one where those rules happen to allow stars and planets and slow, warm worlds and quiet watchers lying awake beneath them. We would find ourselves here, in this particular gentle corner, not because it was designed or chosen for us, but simply because here is one of the places where finding oneself at all is possible. A different corner, with different rules, might hold no stars and no watchers, and so no one there to wonder about it. We are here because here is where wondering can happen. There is a soft and almost tender thought folded inside that idea, and it is worth holding gently. If the rules of nature can vary from place to place, then the particular set of rules we live under, the exact strengths and balances that allow a star to burn steadily for billions of years, that allow a planet to hold an ocean, that allow warmth and chemistry and slow, patient complexity, is a quiet kind of good fortune. Our corner is hospitable. Not chosen for us, perhaps, but hospitable all the same, the way a sheltered cove is hospitable to a small boat. And we are not at the edge of it, or clinging to its rim. We are somewhere comfortably inside it, on a warm world, under a steady sun, in a calm arm of an ordinary galaxy. Whatever lies beyond the horizon, the small region we can actually reach has been, for us, a gentle and a generous place. A broader idea still imagines our entire universe as only one bubble among countless others. It pictures an immense and perhaps endless foam of universes, each one its own bubble, each one sealed away from all the rest, each one perhaps governed by its own physical laws, its own constants, its own rules. The walls between the bubbles, in this picture, are impassable, uncrossable, so that each universe is its own complete and separate world, going its own way, never touching the others, never knowing them. It is an idea that cannot, by its very nature, ever be confirmed or ruled out from inside any single bubble, including our own. And so we hold it most lightly of all, as the most spacious thought there is, a quiet image of our whole enormous universe, with all its trillions of galaxies, as one soft cell in a foam beyond any counting. And then, at the very farthest edge of speculation, there lies the strangest idea of all, the last door in the long hallway. It is the thought that what we call reality might itself be something made, something constructed. That everything, the stars and the worlds and the long dark between them, the whole of it, might be an enormous and unimaginably advanced simulation run by minds whose purposes lie entirely beyond our reach and our understanding. We can mention this one gently, as the last and oddest door, and neither lean on it nor laugh at it, simply notice it. It is one of the ideas that human minds have reached for, sincerely, when they try to imagine what could possibly lie beyond everything. Like the others, like all the ideas in this final part, it can be neither proven nor disproven from where we stand. And so it remains a wonder, rather than a worry, a curiosity to turn over once in the quiet, dark, and then set softly down with the rest. None of these ideas is a thing to fear. Each is only a door left slightly ajar, and we have looked through, gently, and now we may close them again, one by one, and turn around. And now, having stood at the very limit of wondering, having looked through the last of the doors, we come home. It is good to end a long journey by walking back down the ladder we so carefully climbed. So we leave the speculative beyond, gently, without hurry, and we begin to drift back inward, back past the soft, even horizon of the oldest light, back into the great cosmic web, with its long filaments and its broad walls and its quiet, rounded voids, back through the immense supercluster and inward to the local group and into the bright, slow turning wheel of the Milky Way, back along the minor spiral arm where the sun quietly lies, back to the sun itself, one ordinary star among hundreds of billions, warm and steady. Back to the small fleet of outbound probes, still drifting patiently into the dark, exactly where we left them, still going. And back, at last, all the way back, to here. To this room. To you, lying still, and warm, and safe, and held. The vastness has been visited. We have traveled, tonight, as far as traveling can possibly go, and a little further still, out past the edge of everything and into the country of pure wondering. And now all of that immense distance can simply be set down. It does not have to be carried anywhere. It does not have to be solved, or held, or finished. The universe is far too large ever to be finished, and that, in the end, is not a burden at all. It is a comfort. We live at the very dawn of all exploration. The probes are barely past the doorstep of home. The questions are nowhere near answered, and most of them never may be. And all of that is well. It is more than well. There will be more journeys, on more quiet nights, for as long as anyone cares to wonder. But there is nothing more to reach for now. Nothing more that needs doing tonight. So let the great dark settle, the way it always has, the way it always will. The probes are still drifting, gently, outward. The stars are still slowly turning in their long, patient wheel. The rogue planets are still moving warm and quiet through the night. The black holes are still holding their calm places at the hearts of things. And the edge of everything is still glowing, faintly evenly, with its oldest and most patient light. We have been everywhere there is to go, and a little beyond it, and now there is nowhere left to be but here. Let your breathing slow. Let your shoulders soften. Let the vastness grow quiet and gentle around you. There is so much room out there, so much calm and unhurried space, and all of it is at peace, and none of it is in any hurry at all. Sleep well, and good night.